All right, good afternoon, everybody.
Good afternoon. What is this?
This is a couple of charts for the performance of the class on the first exam. First thing I'll point out is the class average here. That's the X bar, that's the average of the class, 79.5. We had 26 students take the test. 25.2 is our standard deviation, sigma. For those of you who know anything about statistics, the standard deviation is actually the number that I'm more interested in, because the average, although it does tell you something about the class, it doesn't tell you everything. The standard deviation kind of is a measurement of how far apart the grades are from one another. And I think we don't even need to look at the number 25.2 to see that we have a huge standard deviation. Normally classes are ranging around 12 points to 14 points. 25-point standard deviation is almost double what I normally see. And what we're seeing here with the A's, B's, C's, D's, and F's is an upside down bell curve. Normally we see bell curves, whenever you, like if you were to measure people's heights, right? You'd have what's called a bell curve, meaning that, oh no, whoa, what was that? Meaning if we had, let's see, the height here, if you measure people's height, and this is how many people are that tall. So like if we say about 5 foot, we're gonna have a lot of people that are about 5 feet or so. Maybe not quite as many that are 6 foot, and not many at all that are 7 feet, all right? 4 foot. So you get this thing that looks like this. That's called a standard normal distribution. And that's what we always hope to see. But as long as I've been teaching and doing math, it's always been the upside down bell curve. It's that flipped over, which means we have quite a few students who seem to understand the material, not much in the middle, and then quite a few students who are struggling with the concepts. So that's always the hardest type of class to actually teach, because I'd like for everyone to be on the same page, but obviously we have huge disparity. So what that means is it's not going to change much in the way I teach the class, okay? The train must keep moving. I must prepare everyone here for Cal 2. Even if you're not taking it, that's the whole job of Cal 1, is to prepare you for Cal 2. So we're going to keep going. If you fall in this group that's on the lower end here, I recommend you try something different, whether that be come to my office hours, go get tutoring, ask for help during class. If I'm saying something, I say, hey, do y'all understand? Actually speak up, say, hey, I don't understand. Whatever you need to do, change what you're doing, because that's usually the first step to getting a different result at the end, is changing our actions, right? So have y'all ever heard of the Einstein quote of insanity?
The definition of insanity?
Yeah, the definition. Einstein had his own definition of insanity, and it was doing the same thing over and over and expecting a different result each time. So if you do the same thing over and over and expect that it's going to be any different, Einstein would call that insanity. All right. So try something different. It's not too late in the semester. It's the first test. So there is time to recuperate, but you must change something. All right. Yeah.
Question.
Yeah.
Where do we get our personal grades?
They should be in Canvas. And I don't know what it looks like from your end, but I've graded the exams and sent them back to you. When I post the grade, I can put an attachment, which is your graded exam. I don't know where that appears for you though. Do you click on your grades and click on the exam and then it comes up as a little file, or is that what it is?
Yeah, it's usually
it has a little
like
attached file on
submission
it.
details.
Yeah, it has a little attached file. So if you open that, that should show you the graded version of your test. so you can see what you've missed or what I took points
Baller.
off for. And
Yeah.
if I remember correctly, normally when I grade test, I take points off. But I think because you could get more than 100 here, I awarded you points. So each problem I graded, it was like plus however many points, plus however many points. And I just added them all up at the end. Okay, I'll let you, if you have questions specific to the exam, about your exam, I'd be happy to talk to you after class. Or come to my office hours and we can discuss things. Any general questions over the exam?
I can't find where you attached our graded exam, sir.
Yeah, I don't know how to help you unless somebody wants to share their screen. Does someone want to share their screen and show us? I wouldn't mind seeing it, but then you'd be sharing your grade. So
On my end, you just go to the grades tab in Canvas, click exam 1, and it should be on the right-hand side of the screen by the comments section.
Yeah, it should be this little like box, a little check-in or whatever. That's where you can like do.
Yeah, so when you're in the grade section and you click on exam 1, the window that pops up on the right side above comments, it says see attached files. You can click on that.
Josh, you don't seem like you're seeing it, no?
I am still not seeing it. In that case, I just have add a comment, media comment, attach file, and save file. There doesn't seem to be any sign that I have a file. There's already a file attached to it.
Did you?
Okay, hold on.
It should
Can
be
you all see
like-
my screen? Can you all see my screen?
Yes.
Yes, okay, hold on. Can you see it now? It changed. Did you see the change or no?
No.
Okay, good. Hold on. I'm gonna see. Maybe there's a chance that maybe one particular student, I forgot to upload the,
Yeah, sorry to be difficult about this.
no, it's all right.
Actually, I'm having the same problem too. Mine isn't showing anything was added.
Yeah, I can, if you want, I can share my screen real quick
Thank
and I can show them where it's at.
Thank you. Okay, so hold on. Let me get back. Let me resume my share and okay, I'm gonna stop sharing mine. Maybe it has something to do with the browser. I don't know. Okay, so go to the course homepage. Yeah, here we go. We can see it.
So I'm, okay, sorry, I was still muted. So I'm at the course homepage. And from there you can just click grades. And then, so I want to click on exam 1 and then it should just pop up right here. You can download it
Are you seeing that, Josh, or no?
and pull it up.
I'm seeing it on his screen. I don't have that on mine. Curiously enough, on the home page for the course for recent feedback, it doesn't have my exam listed as the grade there. I have the exam grade, but it's not showing that on recent feedback and it's not showing the attached file. I wonder if it might be the browser I'm using. I'll try it with another browser real quick.
What
Okay.
browser are you using?
Probably like Chrome.
I'm using Brave, which I think is Chrome based.
I don't know.
I'm using Google Chrome right now for this one. So
I've had a lot of like issues with Canvas using Brave. So I've generally just switched to Chrome for Canvas related things.
All right, I'll try that on Chrome or Microsoft Edge or something. I don't want to keep the class waiting on this any longer.
Yeah, see, I'm on Chrome and I'm just not showing anything was attached to my grade.
Okay, well, we'll have to resolve this outside of class because
Okay.
we need the time, but yeah, that's where it should be. I mean, there is a chance that maybe I forgot to attach your exam to your grade, but we'll deal with that case by case basis.
So
Okay, yeah,
I have one quick question about the exam itself. I just glanced
Yeah.
over my answers and the grading on it, and I understand all of them, the marks that you made, except for the bonus question. I only got half points on that one.
Did you find the
And-
equation of the line or did you just find the slope?
I'm pretty sure I found the equation as well.
Okay,
No, I didn't find the equation. That'll do it.
there were a few students that found the slope of the tangent line, but never actually found the equation of it.
Yep, well, that'll do it.
Okay, all right, well, let's get down to business. So we had started 2.1 and the main concept from 2.1 was that if we're given a function, right, if we're given some function, whatever that may be, okay, whatever it looks like, and then we pick some arbitrary point A, we can find two things that correlate to this point. First thing we can do is we can find the slope of the tangent line, which we abbreviated M with the subscript of tan. And we could do that by taking the limit as x approached A of f of x minus f of A all over x minus A. And that was the big result right there. That was the thing that allowed us to get around the whole 0 over 0 thing. Once we had that, the next thing we could do is we could find the equation of the tangent line. Okay, through that point. And when I say the point, I mean that point right there. It has coordinates A, f of A. So you plug the A in to the function, the x coordinate would be A, the y coordinate would be the function's value at A. So to find the equation of the tangent line, use the good old fashioned y minus y1 equals m times x minus x1. But in this case, we actually know y1, m, and x1. We know all three of those. The y1 is the function's value at A. The slope, well, the slope, unfortunately, that slope is actually that entire limit. So that whole limit, whatever we get for that value is what goes next. So I'll actually write it down. Limit x approaches A, f of x minus f of A over x minus A. Just keep in mind that that's the M. Okay, that right there is the M from the formula. And then x minus A. So the x1 becomes the A. So that's kind of like the master formula for finding the equation of the tangent line. So in the bonus question, I gave you a function, I gave you a point, or I told you what A was. I asked you for number one, the slope of the tangent line, which means you do the limit. And then the second thing I did was ask you for the equation of the tangent line, which means you use that to figure this out, right? You just use that answer and then just plug in your 2 points and you're done. Okay, so I'm ready to move on to the next thing, unless you all want to see just one problem done to kind of get you going again. It's up to y'all. I don't care. You want to see a problem or do you want to move on?
I'm done to see a problem.
Yeah, a quick one would be cool.
Quick one? Okay. So let me just make sure I don't do
In a few
one
days.
that's similar. Yeah, it's been a while. Make sure I don't do one that's similar to the ones I've done. So I did a polynomial. Let's see. I think I've only done, yeah, quadratic, a different polynomial. Then when this was the bonus one that involved the square root. So let me do here. This will be a good one. How about we do this? Find the equation of the tangent line of the function f of x equals 1 over 2 root x. Wait a minute, hold on. Was the one I bonus was a fraction just like that, right? Okay, no, I take that back. I'm going to change it. Sorry. Let's do 1 over x squared at x equals 3. So just as a reminder, what we're doing is we're looking at the graph 1 over x squared. Okay. We're looking at the value 3 here. When we go to this function at 3, which I'll put the point here. That's the point right there. And we're trying to find the equation of the line that goes through that point and is tangent to the curve. That's what we're trying to do. So to do it, we're going to have to first find the slope of the tangent line. So to find the slope of the tangent line, I'm going to do the limit as x approaches what? So what's a for us in this problem?
3.
3. So the a is the 3. So we're going to be approaching 3. And then we're going to be doing f of x minus f of a, which is f of 3, all over x minus a, but a is 3. So you know what I'll do is I'll replace the a with the green 3. That way you realize that this, everything in red is the generic formula. The 3 is what has to be given to us in the problem. We have to know what point we're looking at, right? Because if you're at a different point on the curve, you're going to have a different tangent line. So everything is dictated by this a. Now what we do is we figure out what all these pieces are. So f of x, the top left corner of this fraction, is just the function. So that's just 1 over x squared minus, now f of 3 is what you get when you plug 3 into the function, which is what?
1 over 9.
1/9, right? So 1 over 9. Then that entire thing divided by x minus 3. Now at this point right now, if you let x go to 3, I guarantee you're going to get 0 over 0. Every single time you do this, you have 0 over 0, which is an indeterminate form, right? That means we need to do some algebra, we need to do something, right? So the question becomes, what algebra do we want to use here, right? So you have fractions within fractions. What did I tell y'all to try when you have fractions within fractions?
Combine the 2 on top.
Combine the 2 on top. So get a common denominator between these two. So I will multiply the top here by the left fraction by 9 over 9, and this one over here by x squared over x squared. When I do that, I'll get, let's see, 9 over 9x squared minus x squared over 9x squared all over x minus 3. I'm just showing that step because I want everyone to realize that now you can put them together, right? Because they have the same denominator.
That's a difference of squares on top.
That is a difference of squares on top. And we're probably going to wind up needing that because the bottom is x minus 3. If we factor that, we're going to get something close to x minus 3. It's not going to be exactly the same, but let's go ahead and do it. So we have limit. Notice I'm writing the limit the whole time. Notice I'm not just like forgetting about it. I'm writing it the whole time. Okay, I'm going to factor the numerator. It's 3 plus x, 3 minus x. Be careful of that because it's not x minus 3, x plus 3. It's 3 plus x, 3 minus x. Over the 9x squared. All of that over the x minus 3.
Could we factor a -1 out of that 3 minus x?
Yeah, these two, the two here, this one and this one are almost the same, right? They're almost the same.
Yeah.
They're off by a sign. So we've done this before in the past. We factored a negative out to get them to cancel. So I'm going to factor a negative out of the bottom one. I think because it doesn't matter where you do it. So I'm going to do it off the bottom. Watch. So when I factor a -1 out of the bottom, that changes that to a minus x and then a plus 3, like that. And now these are exactly the same because you can change the order of this. You can write it 3 minus x, right? And still have the -1 out front. So now they cancel. So I'm gonna write the limit one more time. Here's where we are. We have limit x approaches 3. On top, I have a 3 plus x. Below that, I have a 9x squared. And below that, don't forget, you have a -1. Now I let x approach 3. So as x goes to 3, I get 3 plus 3 on top. So no more limit now. 3 plus 3 is 6 over 9 times, okay, 3 squared is 9, so 9 times 9. Then all of that over -1. This turns out to be -6 over 81. And then I can reduce that fraction. That's going to be -2 over 27. 3 goes into both of those, right? This is the slope of the tangent line. This is not the equation. This is the slope. Any questions there? Now we need the equation. So for the equation, we have to be able to use this formula y minus y1 equals m times x minus x1. I know the slope, right? The slope we just got, -2 over 27. X minus, now do we know x1?
That should just be 3, right?
Yeah, that's a. Okay, so that x1 is always a. And then the other side is y minus. Now y1 is what the function spits out when you plug 3 into it, which we found earlier, didn't we? That 1/9? That 1/9? So this is 1/9. Just remember, when we plug 3 into this function, we get 1/9, right? That is a point, that is the point we're talking about. And now you can move everything over. Let me do this. I'll distribute the -2 over 27 through. So when I distribute it over here, let me see, I get positive 2 over, what is that, 9? Positive 2/9, I believe. Because it becomes positive 6 over 27, and then 3 goes into each of those. So I reduced the fraction already. Add 1/9 to both sides. And we should get a final answer here. Y equals -2 over 27x. 2/9 and 1/9 is 3/9, right? And 3/9 is 1/3. You can check this answer, right? Graphically, I'm going to try it. So I'm going to come over here and I'm going to graph y equals -2 over 27 x plus 1/3. There it is. You can see that we have found a line that passes through this point and appears to be tangent to that curve at that point, doesn't it? If you kind of back out and take a look at it, it looks like it's tangent to that curve. All right, we good? Okay, so just when you start getting comfortable with this idea, this formula, we come in and we tell you, well, you know what? We have another formula, all right? That'll do the same exact thing. So that's what I'm going to talk about now, is this other formula. Hold on, I'm getting this flashing thing. Why are you flashing at me? Okay, let me just close this. And this. Okay, so remember where this all started. Okay, this, do you remember? Well, remember where the formula came from. Okay, the formula that we had was that we would start with some point here, right? Which we called A, and that gave us this point right here, A f of A, right? Then we picked a second point. That second point we picked over here, we called this X. And so the point was X f of X. And then what we did is we said, oh, we're going to be taking this line that goes between them, the secant line, and then we're going to slide that second point over. until it lands on top of the other one, right? And when to slide it, to actually move it, we had to let this X approach A, right? That's why in the limit, when we write that limit down, we go limit as X approaches A. The X approaching A is what actually moves that second point closer and closer to the first point, right? That's the whole idea behind that limit, is the sliding of the point. I'm going to do this a slightly different way now, okay? Just slight difference, and it's going to change our formula just ever so slightly. And you're probably going to sit there and go, well, why do we need another formula? Like, we're perfectly happy with the one we have. Well, it turns out that depending on the problem, sometimes one of them is easier to do the work, like the algebra, the limit is easier to do with one of them over the other. So having two is good. I always tell my students, don't get married. Don't marry yourself to one of these like formulas. I've given you one of them, okay? Don't marry it. I'm going to give you a second option, okay? And just don't commit yourself to one or the other. Always be open to both, all right? So here we go. How do we do it? It's the same exact idea, okay? With one little variation. Here it is. First point, same thing. Let's call that A. So that's the point AF of A. Nothing's changed, right? The second point, though, I'm not going to call it X. Okay, my second point over here that I pick. Dang it. I'm going to just do it by hand. The second point that I pick, I'm not calling X. I'm going to call it, well, it's going to be this number plus something. In other words, like if this were 3, right, then this could be 3 plus 1. Would y'all agree that would be bigger than 3? Like, let's just say, for example, this is 3. I know it's not on the graph, doesn't look like 3. Then making this 3 plus 1 would be a number bigger than 3, right? So I'm not going to call it 3 plus 1. If this first one is called A, I'm going to call this A plus, I don't know, something, right? A plus something. Why don't we say A plus H? Okay. And that'll give me a second point over here. Now, what are the coordinates of that point? What's the X coordinate?
A plus H.
A plus H, yeah.
A plus H, right? Okay, that's what's being plugged
Yeah,
in.
it would be F of A plus H on your other.
The Y coordinate would be F evaluated at that point, A plus H, right? Now, same idea. We draw a line through it, and then we want to slide that second point over. How can you slide the second point over? What will my limit have to do? What will this piece have to look like if I want to make this point here move towards that point?
H would approach 0.
H will have to get smaller. Do y'all agree with that? Think about it. Whatever H is, the smaller H gets, the closer this point starts to move towards A, right? So if it's like A plus a half, that would be close to A, but A plus a fourth would be even closer. A plus a tenth would be even closer. A plus 1/100th even closer, right? So to move this point over to A, we want that H to go to 0, and it'll slide it across. Yay or nay? Yes.
Sounds good to me.
Okay, so
Yeah.
that means we're going to have this limit as H approaches 0. And then the rest of the formula is just your good old rise over run again. So the difference of the Y coordinates is the difference of this coordinate and that coordinate. So that's your change in Y should be the F of A plus H minus F of A. And then you divide that by the change in X. The change in X should be the difference of these two values, which should be A plus H, take away what?
A?
A, okay. Right?
Is this the
Now, it
difference
turns out-
question?
Now that
On the bottom, the A's go away, don't they? And this leads us to our final master formula here, limit h goes to 0 of f of a plus h minus f of a all over h.
Sir, I mentioned earlier, is this the difference quotient?
That's the difference quotient from college algebra, yes. Well, in college algebra, they don't put the limit out here, do they? But they make you do this over and over. And hopefully your college algebra teacher told you, because when you get to calculus, you have to use it again.
I remember that.
That's okay, yeah.
Yeah.
Now, I'm gonna tell you right now, this is the one that we prefer, all right? This is the one that's used more often, especially when we get to the next section. You'll see why in a minute. Well, you'll see why later. Okay, so look, everyone, this is the same, you get the same result using this formula than you do using the other formula. And to prove it to you, I'm gonna go back to, let me do a quick screenshot of this. I'm going to go back to the notes. Okay, and I'm going to redo this problem right here. I'm going to redo it with our new formula. This new formula will also give us the slope of the tangent line. Let's prove that it will. And then we can talk about which was easier. Okay, so let's first find the slope of the tangent line, which now with the new definition is the limit as h goes to 0. I'll write the whole formula down again. F of a plus h minus f of a all over h. But for us, a is 3, right? A is 3. So this will become limit h approaches 0. Okay, f of 3 plus h minus f of 3 all over h. So all I did there was replace the a's here with 3's, right? Now we actually have to figure out what the function is going to do with those inputs. So when I plug 3 plus h into this particular function, it will give me 1 over 3 plus h squared. Do y'all agree? That's the top left corner of this. That's this right here. That's what happens when you plug 3 plus h into that function, right? I subtract from that f of 3. Now f of 3 we know already, right? You just plug 3 in here, it's 1/9. All of this over what? H, right? Are we clear? Now, in the last problem, when we had this, we had to combine the two fractions together, right? It looks like we're gonna have to do the same thing here, right? We have to get a common denominator between these two. Okay. So I multiply this by 9 over 9. And this one, ooh, I have to multiply it by 3 plus h squared over 3 plus h squared. That kind of sucks.
I have a question.
Yes.
How did you go from f of 3 plus h to 1 over 3 plus h squared?
This is the function, right? This is the function we're talking
okay.
about? Yeah, okay, yeah, so this is for this specific function. If I change the function, f of 3 plus h is something different, right?
Gotcha. Okay.
Everyone clear on that? Taking 3 plus h, plugging in right there for x. The whole thing gets squared, right? The whole thing. The 3 plus h, the whole quantity gets squared. All right, this is, all right, it is what it is. I'm feeling like the algebra here might be uglier. Let's see. Okay, so when I do this, I'm going to go a little faster on this one. I'm going to get 9. That's the 9 times 1, then minus. And then over here, I've got the 3 plus h squared. That's all over the common denominator. The common denominator is 9 times 3 plus h squared. And then all of that is over h. So I skipped a step here. I put those together all kind of in one step. Any ideas of what to do now?
I'd say square out our 3 plus h squared on the top, because I'm thinking we'll get a 9 up there that'll cancel out our 9.
Yeah, see, the ultimate goal here is to get this h to go away down here.
Because
Okay.
if we can cancel out our 9, then we should, well, that doesn't really matter, but we should end up with being able to factor out an h if we cancel out that 9.
Everything should probably have an h in it. Let's do this. Be very careful with this minus. That minus is going to distribute to everything this becomes. Now, I'm trusting that you can multiply that out on your own. Foil it, right? Collect like terms. I hope that everyone's comfortable with that becoming this. But I have to subtract it. So I have to subtract every term. Minus 9, minus 6h, minus h squared. All over 9, 3 plus h squared, all over h. All right, the 9s do indeed go away. All right, they go away. So my next line, I get to copy paste. My next line now has those 9s gone, right? Which means now I can factor an h out of the top, right? Because these two both have h's. So I'm going to do that. Pull that h out, I'm left with -6 minus 1h there, all over the 9 times 3 plus h squared. All of that still over h. And this is the point we were finally hoping to get to. This h and this h go away. So you get the limit, h goes to 0. See, my limit was there the whole time, isn't that great? Okay, -6 minus h on top, and then on the bottom, 9, and then 3 plus h squared. And now take the limit, let h go to 0. So what will be left on top?
6, -6.
Okay, and on the bottom, if you let that h right there go to 0, that just becomes 3 squared, right? Instead of 3 plus h, just becomes 3 squared, which is 9. And then you had a 9 in front of that, so 9 times 9, that's 81. And we already recognized that, right? Same answer. And then to get the equation, you do the same thing before, right? You just use the y1 and the x1. And
Optimal.
so what do y'all think? I mean, comparing this algebra to the other one, you have a preference?
The top one, like the first one we did, was much simpler for this particular problem.
I think
So it's
I think so too. I think I prefer the other one, but they both get you to the same result, right?
So when we're faced with like a problem, how do we know which one to do? Is there like a kind of like a giveaway of like, oh, I should probably use this one over this one?
Not really. There's nothing, there's not like a thing where I can say, oh, whenever you see this, use the first formula. Whenever you see this, use the second formula. There's no like dead giveaway for it. I would just say if you do it and you use the first formula and you find yourself getting stuck with the algebra, maybe just try the other one. Now, let me give you an example. Let's do an example of one where it's an obvious difference between the two. Okay, where there's just an obvious difference between which two to use, which of the two to use. Okay, how about this one? Let's just find the slope. Let's not do the equation. Find the slope of the tangent to f of x equals x to the 4th at x equals 2. All right, so let's do the first one first, right? The first formula. So the first formula was slope of tangent line equals the limit as x approaches a, f of x minus f of a over x minus a. Here a is 2, so I'm going to let x approach 2, and this will be x to the 4th, that's f of x, minus, what's f of 2?
2 to the 4th.
2 to the 4th, which is
16.
16, then over x minus 2. Okay, is that all right? I just jumped right to this. I did f of x, which was x to the 4th. I did f of 2. Remember, this is 2, because that's what a is here. That's 2. And how would you do this?
Well, it's a difference of
That'd be different
squares
squares.
on top, so.
Yeah, difference of squares on top. So this one would be x squared plus 4 over x squared minus 4 on top. Like that, I can do that. That does not break down, right? I'm sorry, that doesn't cancel. So I have another difference of squares here, though. Do you see the second difference of squares? So I can go again, difference of squares second time. I have to leave the x squared plus 4 alone. The other one becomes x plus 2x minus 2. All over x minus 2. And the x minus 2 factors cancel now. So we had to do difference of squares twice. And now this becomes, well, we can just take the limit now, right? Let x go to 2. So we should get 2 squared plus 4 times 2 plus 2. 2 squared is 4, 4 plus 4 is 8 times 4, so you should get 32. That wasn't too bad, right? Different squares twice.
I feel like the second way is going to be much worse.
I think the second way is going to be worse. So how would we know that? Let's see.
This
The
first one was
second
so
way-
easy.
We do limit h goes to 0, f of a plus h minus f of a all over h, right? Now a here is 2, so I'll plug 2 in since this is only the second time we've used this formula. That means we want to do f of 2 plus h minus f of 2 all over h. So Maddie, this is where, like in the last problem, when we're trying to figure out what this is, it's going to be specific to the actual function we're talking about. So when we plug 2 plus h in there, right, it's going to be 2 plus h to the 4th power. Minus f of 2. F of 2 is 16, isn't it? Over h. Questions on how I got any of this? Okay, the goal is to try and get an h to cancel. But nothing cancels yet. We're going to probably need to expand this out, which means we're going to have to do 2 plus h times 2 plus h times 2 plus h times 2 plus h. And you probably don't want to do that, right? I mean, it's a lot of work.
Could we
Isn't that
treat
top
this as
make
a
a difference of squares?
Yeah,
You could treat the top as a difference of squares. You could. It'll work similar to the other one, but I think it's probably clear at this point that the first method seemed better for this one. Yeah?
yeah.
Okay. So I know I'm not doing a good job selling the second one here. All right. I know I'm not. But it's the one we use the most. All right. And you just have to wait. You'll see when we get to the next section why. Okay.
So basically, the way to tell is if you start doing it and it looks like a bastard, try the other way and see if it's better.
Yeah. Yeah. You could go with that. All right. So here's an exercise that I'd like for us to take on here. I'm going to give us f of x. I'm going to give you a function here. And let me pick something. Yeah. Let's do x over 3x plus 1. There's your function. Now that's a little complicated, right? And I want you to find the slope of the tangent line. I'm not asking for the equation, just the slope. The equation's a little more work, right? But it can be done. Okay, I just want the slope of the tangent line at x equals, well, actually, I want you to figure it out at a few different places. I want you to tell me what the slope of the tangent line is at, let's see, A. At x is, well, you know what, let me change this. At x is, let's say, 0. I'd like for you to find it at x is 3. How about at x is -5? How about at x is 10? And I'll just throw one more. X is 1. Write it all down, then we'll talk about it. While you're writing it down, I'm going to graph the function. Okay, got it? Here's the graph of the function. And what I want you to do is figure out what the slope of the tangent line is at various points. So somebody tell me, where was the first point I said?
0.
0.
At 0. So right here at 0, there's some tangent line. I'd like to know the slope of that tangent line. Where else?
3.
3.
3 is about right here. So go there, find me the slope of that tangent line. Where else?
-5.
-5, that's over here. I want you to find me the slope of the tangent line over here. Where else?
10.
10. Oh, that's way over here. It's kind of off my graph over there. Where else? Anywhere else?
1.
1.
So here, right there. Now we're going to have different slopes, aren't we? For each of those points, different slopes.
Yep.
Which means you're going to have to do how many limits?
5.
5 different limits. Right? That's going to suck, isn't it? So
Just 5 problems.
it's 5 problems, but come on, it can't.
How about no?
Yeah, but no, yeah. How about we don't work hard, we work smart. How about we try something else? How about we try and do it where we find the slope of the tangent line at an arbitrary point? And that's what I mean is, instead of fixing x to be a number, why don't we let that x be a variable and then do all the algebra and get a final result that is more like a formula for the slope of the tangent line for this particular function. So let me do this.
Batman.
Let's first do the problem. Let's first do the problem for one of these, just to appreciate the work that it's going to take. And I'm going to do the one for B first, because the one for A is a little bit too easy. All right, so if we were to not be trying to work smart, just grind through this, then we say, okay, for part B, the slope of the tangent line would be equal to the limit. Now I have to decide which formula. Which formula y'all want? First one or second?
Second.
Second? Okay, I heard
Yeah, let's
second.
try second.
Second.
Limit h goes to 0. F of a plus h minus f of a all over h, right? But what would a be for part B? What's a for part B?
3.
3.
3, right? So this limit becomes limit h approaches 0, f of 3 plus h minus f of 3 all over h. Okay, can we plug 3 plus h into that function? We can, but it's gonna
Yeah.
suck.
It's
Yeah,
it's
that's gonna be
awful, but
horrible.
we do it.
Limit h goes to 0. Okay, if I replace the x's in here with 3 plus h's, I get 3 plus h on top. I get 3 times 3 plus h, then plus 1. Everyone see that? That's just the original function evaluated at 3 plus h. Subtract from that f of 3. So what do you get when you plug 3 into this?
3/10.
3 over 10.
Yeah,
3
negative.
over 10.
Yeah, 3
3
over
over
10.
10. And then all of this over
H.
h. Eey, that sucks. Doesn't that suck? Give myself a little bit more space in there. Okay, common denominator. Ready? Common denominator. I'm going to multiply the first fraction by 10 over 10. And then the other fraction, unfortunately, I have to multiply it times that ugly thing, the whole thing. So I'm getting a common denominator, right? Right, on the first one, when I multiply that 10 through the top, I get 30 plus 10h. Then minus, okay, I think I'd like to figure out what all this is over here. Let me figure out what all of that is over here, and then I'll bring it back in. So I have 3 times 3 times 3 plus h plus 1. I'm going to do everything in this parentheses first. I'm going to distribute that 3 through, so I get 9 plus 3h plus 1. Combine the 9 and 1 together to get 3 times 10 plus 3h. And distribute a 3 through to get 30 plus 9h. With me?
Yes.
Okay, that's what the new second fractions numerator becomes. But I have to subtract it, don't I? Subtract everything here. So that means I'm going to have minus 30 minus 9h. Any questions on where this comes from? Do not forget, this is all over the common denominator, which is 10 times 3 plus h plus 1. All of that is divided by h. Don't forget the h from the whole formula, right? Do we get good things on top?
Yeah, we can cancel out a bit, everything but an H.
Yeah, 30s go away, right? Those are gone. 10h, take away 9h, that's 1h, right? So this and this together give me just an h up here.
Yep. We cancel that with bottom.
And that h will cancel with that. Now, when we cancel it on the top, there's nothing left on top, right? So we have to leave something there, right?
Yeah, it's left with the 1.
Got to leave a 1 there. So we have 1 over 10 times 3 times 3 plus h plus 1. Oh, I think we're almost there.
It's solved for
Now we
now.
let h go to 0, right? Let h go to 0. So if this h here goes to 0, then this becomes 3 times 3, which is 9, right? Plus 1, which is 10. And then times 10, which is 100. So we get 1 over 100. That's the slope of the tangent line at x equals 3. Feel good?
No.
Thank you, Ethan. I appreciate honesty.
That was an interesting one.
It would suck to have to continue to do this for the remaining 4, right? So what we start to do is we say, all right, again, let's work hard. I mean, let's not work hard. Let's not work hard. Let's work smart, not hard. All right. So what we're going to do now is we're going to say, all right, That's fun. Yeah, don't feel like it. What about just finding the slope of the tangent line to this function at x equals a? I'm not gonna tell you 3 or 0 or 5 or 10, just a, okay? Well, what's the formula? The formula, let's use the second one again. It's a limit as h goes to 0 of f of a plus h minus f of a all over h, right? That's the formula. I'm not going to replace a with a number now, though. Okay, I'm not going to replace it with a number. Now, let me go grab the function because I'm going to need it. Okay, so for this particular function that we're talking about here, we can figure out what f of a plus h is, right? If I ask you to plug a plus h into this function for your x's, you will get an expression that looks like this. Limit h goes to 0. Okay, what's the top? Replacing the x with a plus h.
Yeah,
right?
a plus h
A plus
over
h.
3 times a plus h plus 1.
Over 3 times a plus h plus 1, right? See, I'm leaving a as a. I'm not telling you what a is. Now I need to subtract from that f of a. Now in previous problems, this f of a has always turned out to be a number because we're just plugging a number into the function. This time we're not plugging a number in, we're plugging a in, right? So our answers, replace these with a's. It should just be a over 3a plus 1, right? That's what you get when you plug a in. Real good? All of this divided by what?
H.
H. Okay, so look, we're going to go about this the same way we did the previous problem. We are going to get a common denominator between these. All right. Now I'm going to do one step more before I get a common denominator to kind of help us with the algebra a little bit. On this bottom left, I'm going to distribute the 3 through. Okay, this 3 through that parenthesis. I get 3a plus 3h plus 1. That's this right here. I still have minus a over 3a plus 1 all over h. Now your common denominator, right? Your common denominator. So I will multiply the first fraction over here by what?
3a plus 1.
3a plus 1. Okay. We got to do that here and here. Now the other one, yes, this is your life. What do you have to multiply it by?
3a plus 3h plus
3a plus 3h plus 1. Same thing here, 3a plus 3h plus 1. This is why you did this in algebra, right? In algebra, they had you like take two rational expressions and combine them into one fraction. This is why you were doing it, so that when you got here, you'd have some background with it. All right, now I'm going to multiply this out with the little foil there. Okay, that first multiplication, 3a times a gives me 3a squared. Then 3a times h is 3ah. And then 1 times a is a. And then 1 times h is h. That is the top left multiplied out. Minus. Now I'm going to do this right here. Actually, it's not that hard because all I'm doing is multiplying an a through. Right? That's all you're doing. Just multiplying a through here. So that would becomes 3a squared plus 3ah plus a. And we will subtract it all, right? Subtract it. So that changes the signs of everything. Who wants to tell me what the next part will be?
Well, then that'll basically, those should just completely cancel each other
Well, I'm
out.
saying, what do I write next?
Oh, you write that as all in as negatives.
Okay, so minus 3a squared minus 3ah minus a.
Yeah.
Right?
Those should all subtract out except for the H.
Yeah, all of this, right? Over the common denominator, do not forget the common denominator. The common denominator is 3a plus 1 times 3a plus 3h plus 1. And then all of that over h. And now the good things happen. Three a squared minus 3a squared, gone. 3ah minus 3ah, gone. A minus a, gone. The only thing left on top is h, right? All we have is an h. And now that h will reduce out, that becomes a 1, that becomes a 1, so it's basically gone. So all we have left is, it's still ugly as, you know, can be, but we don't have division by 0 anymore. Last step, let h go to 0. When you do that, this term goes away. Everything else is still there. That's the only term that has an h in it, right? So what you're left with is a 1 on top, then over 3a plus 1. And then the other parenthesis is also a 3a plus 1, isn't it?
Yeah, so it could be 3a plus 1 squared.
So you can put 1 over 3a plus 1 squared. This is a formula, right? This is a formula for the slope of the tangent line at x equals a. And now you just start feeding me a's. So what did we do earlier? 3? Wasn't the problem? Didn't we plug?
Yeah, we
3
did
in
3.
earlier? And we got 1 over 100, didn't we? Well, plug 3 in
Yeah.
here. What's 3 times 3 plus 1?
10 squared.
10 squared is 100. It's 1 over 100. But now I can start cranking them out, right? Give me another a, and I'll put it in here, right? So let's
0.
let's take this here, and let's go back to the original question. Now that we have a formula, and let's answer these.
Wait, I'm sorry, what happened to the 3H?
Okay, so remember, this was all a limit, right? Limit, limit, limit until this step. At this step, h went to 0, right? I finally let h go to 0. And when h goes to 0, it basically makes that go away.
Gotcha, just wanted to.
That's the limit, right? And that's why in the next line, there's no limit, right? Because we actually let the h go to 0. And Maddie, you can't do the, if you try and do the limit anytime sooner than that, you're getting division by 0. See, we had to have this h cancel for us to not have that division by 0. So all that work, all that algebra was just to get the h to go away.
Pretty much
All
the
right.
same as the last chapter.
Yeah, yeah. All the limits we've done have been to try and get that thing to cancel so we can get an answer. All right, so let's do this. If we want the slope of the tangent line at x is 0, then I'm just going to use that formula. I'm going to put 1 over 3 times 0 plus 1 squared, which is what?
1 over 1.
1 over 1. It's 1. So back on the picture here, when we go to 0, right? And I wanted to know, what is the slope of that tangent line? What did we just say it is?
1.
1, and it makes sense. Doesn't it look like it is?
Yeah,
1?
no, I was gonna say earlier when we had this, I was gonna say I'm gonna bet that's a slope of 1 just looking at it.
It looks like it, right?
Yeah.
And it matches up. It looks, I mean, it is. We also did the slope at what, 3? Now that's harder to tell what it was, right? Because it's a very, very flat looking line. That line that goes through there, sorry. And we already determined what was the slope of that line.
1 over 100.
1 over 100, that means you go up 1 over 100. So it's a very shallow line, almost flat. Okay. All right, so 3, we already did this. That was 1/100, but you see how you can just start cranking them out now? Here we
Yeah,
go
it's like a
1
fifth at a time.
That one's like 1/256.
Yeah, it's probably a big number, right? So you get
Yeah.
1 over, this is -15. Plus 1 is -14, but then you
I
square
messed up
it.
my math.
That's all right. What is that?
196.
196?
Mhm.
1/196. This one's gonna be a very, very shallow slope. 1/3 times 10 plus 1 squared. So this is 1/31 squared. 1 over big number,
961.
961. And then at 1, we should just get 116. Right, plug in 1 into that formula, you get 3 plus 1 is 4, 4 squared is 16. So the moral of the story is this. If you're given a function and you're asked to find the slope of the tangent line, if there's any chance at all that you're going to need the slope of the tangent line at various points, then it's worth it to get a general answer as opposed to doing it over and over and over and over. Because you would have to have done, what, 5 different limits? If you just did the general one the first time, then you're set, right? You're set now. Make sense? Now, what's going to become the issue for you is the algebra, right? Now the algebra starts to get real messy. As you start to mess with different types of functions, you'll see how the algebra starts to move. Okay, so going back, let's see, to our notes, we are done with this. This is the new definition. In the notes, this is the new definition for the slope of the tangent line. It's our second version. That's what I called in the notes, the second version of the tangent line, or slope of the tangent line. And there are a few other things that we need to kind of wrap up this section, right? We have 2 formulas for the slope of the tangent line, right? Because we want to actually do this a lot, okay? So there are many times throughout the rest of this course and further calculus courses where I'm going to want you to continue to do this. Find me the slope of the tangent line. Find me the slope of the tangent line. Find me the slope of the tangent line. We have a notation that we use that I can write that'll let you know to do that. Okay? So some notation here. If we write f of x like this, and I want you to find the slope of the tangent line at x equals a, right? If I want to tell you to do that, all right, I will no longer write this anymore, okay? Here's what I'm going to write. F with a little prime mark there, and then in parentheses a. That little prime, this is a, we call that the prime mark, okay? It's like an apostrophe, okay?
Yeah, I remember that.
Okay, that right there, that little symbol tells you to go find me the slope of the tangent line. Okay, that's all. It's very simple, very simple symbol. All right. So that's what the way we'd read this. If you were trying to say this to someone, you would say f prime of a. And what is f prime of a? F prime of a is the slope of the tangent line to that function at a. Again, f prime of a is the slope of the tangent line to that function at a. So that's what the notes are saying here. Okay, now we have a name for it. Okay, this is the notation, but this is used so much, okay, that this is known as the derivative of f at a. It's the first time we're officially using this word derivative. So if I give you a function, right? I say, hey, here you go, Theodore, here's a function, right? Go figure out what the derivative of f is at a. What I'm asking you to do is to go find the slope of the tangent line to that function at a, right? This is all just notation and language now, all right? And remember when we started this class, I don't know if I told you all this, I think I did. Cal 1 is called differential calculus. Cal 2 is called integral calculus. So Cal 1 is about this thing called differentiation, which is basically finding derivatives of functions. Okay, so mostly Cal 1 is all about finding the derivative of a function. Cal 2 is about, well, something else. It's the reverse process. Okay, so that's notation, the derivative, some language. Some more stuff here. Make this a little bit bigger. Okay, so note f prime of a. See, now I'm going to start using that notation, so you need to understand what that means now. F prime of a can be viewed as the instantaneous rate of change of something. The instantaneous rate of change. The derivative of f at a not only represents the slope of the tangent line, not only is it physically the slope of the tangent line, it also represents the instantaneous rate of change of the function at the number a. So let me try and illustrate this with something more visual. If we take a graph and we take some point on this graph that corresponds to a here, let's say that the x-axis represents time and the y-axis represents distance. And for the sake of making this easy, let's make it hours. And let's make distance in miles. Then if I said, hey, what's f prime of a here, right? F prime of a is going to be the slope, right? The slope of that line. At x is a, right? That's what it is. But within the context of this particular function, it represents the instantaneous rate of change of that function at that point. So remember, the slope is always rise over run, right? Always rise over run. So if we look at our rise is measured in miles and our run is measured in hours, then that slope of that tangent line, the units that we would measure our answer in would be in what rise over run would be miles over hour. So it would be whatever the answer is, right? Some numerical answer, miles per hour, which means it's measuring your speed at that instant in time. It's a way of measuring the instantaneous rate of change of the function at some point. I started class with this idea, didn't I? Like the idea of, can you actually talk about the speed of something at an instant? We actually have a way of doing this now. Just kind of making sense? Instantaneous rate of change. It does not have to be miles, hours and miles though. It can be anything. So let's say you have some other graph where this is, I don't know, I'm trying to think of something. Let's stick with time here just to make it easy. And then let's say this is temperature. And maybe time is measured in seconds. And maybe the temperature is measured in Fahrenheit. Oops. Which one? I had that right, didn't I? Fahrenheit. So if we have something that's measuring the temperature, like outside today, it's supposed to drop off later, isn't it?
Yeah, I think there's both. Mark.
Yeah, so if this is a graph that's measuring, you know, at every second we're measuring the temperature outside, then we have a graph of it. If we pick some arbitrary point A, go to it, if we find the slope of this tangent line, in other words, if we find f prime of A, what that will be is the instantaneous rate of change of this function at that point. What would the units be here? So in the previous one, it was miles per hour, right? It was
This
this
one would be degrees
rise
per
over,
second.
this would be what?
Degrees Fahrenheit per second.
Degrees Fahrenheit per second. So let's just say, for the sake of acting like we actually had this calculation, let's say that the slope there was -1. What that would mean is at that instant in time, right at that instant, your temperature was dropping by 1 degree a second. And this can be extended to any two quantities that you can measure and put together. Force over distance, force over time. You know, you want to measure chemical reactions. You're trying to figure out, you know, how many moles of something there are at a given point in time. Anything, physics, chemistry, biology, doesn't matter. If you've got a function, we now have a way of measuring at any point on that function the instantaneous rate at which it's changing. The instantaneous rate. So this extends to everything. Now, the catch is you have to be able to calculate the derivative, right? You have to be able to take the limit as h goes to 0 of f of a plus h minus f of a all over h. You've got to be able to do that in order to answer the question, but we have a way of doing it. Okay. Now, if we are talking about, if we are in a scenario where the function we're looking at gives the linear displacement of an object as a function of time. In other words, it measures the distance over time. Then the derivative is your instantaneous velocity. That was the first example I gave you. So if we're measuring how far something has gone at a certain point in time, then the derivative at a point will give you the speed of the object at that instant in time. So that is a specific example. All right, that is it for that section. I feel like we should do one more. Yeah, I want to give you one to work. How about we do that? Let's do breakout rooms. Let's do one problem here, you to work on together, okay? The function is f of x equals 5x over 1 plus x squared. And I want you to find f prime of a. I think this will probably take us to the end of class. So let's go for 15 minutes. And then after 15 minutes, we'll come back together as a group and talk about it. All right. But I want you to please, you know, try and talk to each other through the algebra of this problem, because the algebra in this problem is, well, as you probably suspect, is probably going to be pretty messy. Breakout. Any questions before I put you in breakout rooms? We'll go 3 to 4. Do you want it small and intimate, or do you want like a party? What do y'all want? Don't care.
3 or 4 should be fine.
3 or 4? Okay, so here we go. You should be invited to a room. I'm gonna work through this. All right, so the derivative at A is the limit. I'm gonna go with the h goes to 0 formula. So limits h goes 0 of f of a plus h minus f of a all over h. That's our generic formula. So this must be equal to, or this will be equal to. All right, now replacing a plus h in all the x's here, we get 5 times a plus h over 1 plus a plus h squared. All right, now we subtract from that f of a, which would be 5a over 1 plus a squared, then all of that over h. All right, I'm going to need a common denominator. So I need to multiply the top here by 1 plus a squared, and the bottom here by 1 plus a squared. And then over here, this is going to be 1 plus a plus h squared multiplied on the top and bottom. Yeah, that's going to be fun. Okay, so for this one, I think I'll do this one on the side here. I'm doing, let me move the 5 out front. I'm doing 1 plus a squared times a plus h. So first, let me do the 5, and then let me multiply this out. So I get a plus h plus a cubed plus a squared h. And then I multiply a 5 through, so 5a plus 5h plus 5a cubed plus 5a squared h. Okay, all of that is just that multiplied. Okay, I'll come back. I'm going to rewrite this. I'm going to take care of the next piece, which is this multiplied through. I'm going to do that over here. This is 5a. And then I have 1 plus, now I have to square a plus h. Now, I hope you can do a plus h times a plus h. It'll give you a squared plus 2ah plus h squared. Okay, so that's that thing squared. I still have a 1 in front of it, 1 plus that. Now distribute a 5 through. So 5a plus 5a cubed plus 10ah, and then last one plus 5h squared. So that is this, and I'm supposed to subtract, right? So this yellow one minus that blue one, the minus will distribute through to all those, then my common denominator, then all over h. So here we go. Limit h goes to 0. Okay, this yellow piece first, 5a plus 5h plus 5a cubed plus 5a squared h minus, now I'm subtracting each of these, so minus 5a cubed minus 10ah minus 5h squared. Okay, all of that divided by the common denominator, which are these two things multiplied together. So 1 plus a squared times, in parentheses, 1 plus a plus h squared, all of that, everything divided by h. All right, I'm hoping for the best here. 5a, take away 5a. 5a cubed. That is it. That's all that cancels. Okay, but everything that's left has an h. Everything that's left has an h. Please notice that. H here, there's an h here, there's an h here, there's an h squared there. So I'm going to pull an h out of each of those on the top. H, I got a 5 there, plus 5a squared. Okay, on the last one, or the second to last one, I pull that h, I get minus 10a. Pull an h out of the very last one, minus 5h. All over my common denominator. And then all of that over h, and that's when the h's go away. So now at this point, I can let H go to 0. So everywhere I see an H, those terms are going to go away. So that goes away, that goes away. That's about it. So all that's left is 5 plus 5a squared minus 10a. This thing in blue is completely gone. Over, okay, I have 1 plus a squared in parentheses. And then if I let this h go away, then I have just a squared here. So that's 1 plus a squared again. And so you could write this as 5 plus 5a squared minus 10a over 1 plus a squared squared. There we go. That is our general formula for the slope of the tangent line at A. Give everyone more time here.